Most programmers solve this problem wrong. They try greedy and instantly fail. But one tiny DP trick gives the maximum jumps in seconds. Want full solution? Check this video.
Hi everyone and welcome back. Imagine you are standing at index 0 and you can only jump if the difference between two numbers is within target value. Sound easy? Well, the trick is finding the maximum number of jumps before reaching the last index, and many people overcomplicated this problem. So, in this video, I'll show you the cleanest dynamic programming solution step by step. So, let's program. We are given an array called nums and an integer target. From index 0, we can jump to from index I, we can jump to index j if the absolute value of num of I minus num of j is less than or equal to target. Our goal is not to minimize jumps. We actually want the maximum number of jumps needed to reach the last index. And if reaching the last index is impossible, we return -1. So let's take an example. Here we have the array nums with this value and target value equals 2. So we are initially started at index 0, so we can jump from 1 to 3 because the difference is 2, which is less than or equal to target. And then we can jump from 3 to 4 because still the difference is less than the target. We can't jump from 3 to 6 because the difference here is 3, which is greater than the target. So the second move is from 3 to 4, and then we can jump from 4 to 2. Again, we can jump from 4 to 1 because the absolute difference between these two numbers is greater than 2. And eventually, we will reach the last index. Now, notice something important. At every position, we want to know the maximum jumps needed to reach that position. And as you know, in most cases, when you hear the word minimum or maximum, we should immediately think of dynamic programming. So to solve this problem, we need to create a dynamic program, the DB array. So first, we will define our DB array, and it should be of the same size of num. And each index in our DB array, so each DB of I means the maximum number of jumps needed to reach index I. So initially, everything is unreachable, and for that, we will initial our DB array first by -1, except for DB of 0, because at this index, we start initially at this index, so we have 0 number of jumps. Now, for every index I, we check all previous indices j. For example, if I equals 2, that means that we need to check all the previous indices j, which will be in this case 0 and 1. And for each j index, we need to check two things. First, that j is reachable, which means that dB of j doesn't equal -1. And second, that we can jump from index j to index I. And to validate this, we need to make sure that the absolute difference between num of I and num of j is less than or equals to target. And if the two conditions are valid, that means that the transition is okay and we can jump from index j to index I. So the equation to solve this problem is that the dB of I will equal the maximum of the current dB and the previous dB or dB of j plus 1. So let's walk through the code. First, we need to get the size of the array. So we will define a variable n equal nums dot size. After that, we define our db array. So we'll define a vector of integer, name it db of size n, and we will initialize its values by -1. And as we have said, we will initialize the first element of our array, db of 0, to the value 0, because here we need 0 number of jumps. After that, we iterate from I equal 1 till n minus 1. So for int I equal 1 and I is less than n and plus I, and we will iterate over all the indices before I. So for int j equals 0 and j is less than I plus j. First, we need to skip unreachable positions. Early. So we'll check if our dB of j equal -1. So this means that this position is unreachable. So we continue. Otherwise, we have a valid jump. So if the absolute value between nums of I minus nums of j is less than or equal to target, then we apply our transition equation. So our dB of I will equal the maximum of dB of I and dB of j plus 1. And after we complete our iteration, our result should be reside in the last element in our db array. So let's run it, make sure no errors. Let's submit it. And in terms of time complexity here is n squared, because for every index we check all previous indices. And in terms of space complexity, it is O of n, because we are defining a DP array. And that's it for today's solution, a very clean dynamic programming problem. Once you define the DB state correctly, it became very straightforward and easy. I hope this explanation helped you, and don't forget to like the video and subscribe to the channel. And as always, see you in next video. Bye.